Hi guys. Okay, this is a little bit not exactly from the sequel that we are doing. We're going to go to chapter 3 on algorithms, but before we do that, I want to go over with you on this topic, which is actually covered in the book as Appendix 3, and it starts at page A11. So page A11 and forward. It's all the way at the back of the book. What does it mean by pseudocode? Code here refers to coding in the sense of computer science, writing a program coding, but we're not going to actually do programming. So some of you might be disappointed in that. And that also means that we are not going to stick to one particular coding language. You might have, depending on when have you learned computer science coding or whether you ever learned it. I grew up with BASIC and then other program languages very long time ago. Nowadays we have Java and R and whatnot. I don't even know anything anymore, and that's because the proliferation of all these different programming languages. They all have a functionality that is different depending on what they want to do. One has come up somehow. The community has come up with what is called a pseudo-code, meaning it's not actual machine code, but it is something that is almost ready to put into a programming language. In other words, it's the stage before you actually translate it into the language, and it makes it basically available in. If you write a program in pseudocode, that anybody can later on implement its own version in its own preferred language. So it has really an advantage to have this pseudocode. Now, I agree, it's not something that is a universal standard yet, but it is somehow uses some universal principles that are common to all coding languages, or almost all coding languages, that it makes it understandable almost for every programmer. And so I want to give a short introduction in the type of pseudocode that we will use. So we will use a lot of pseudocoding. We'll write programs, but we'll never actually implement them. So it's not that a computer will carry them out. But I need to give you a little bit of a short course into programming if you want, but using pseudocode. And pseudocode is also developed to be extremely simple, in the sense that there are very few commands. And commands will always have a special typeface. In the book, they always use blackboard, a boldface. I'm going to use this face. And so one of them is how you start is called procedure. So that is one of the first. So whenever I use this grayish, thicker font, then I'm using a word, a command word that has a meaning in pseudocode, that is defined in pseudocode. And so procedure, what is procedure, is exactly the name of the program, right? It just says, okay, here's now, after procedure, there will become parentheses, and in this parentheses, I will tell you what this procedure acts upon. So this is the input. Now, depending on the program language, you have to do a lot of declaring variables, say what type they are, and there's a lot of subtleties that are involved here that we completely wave our hands, and we say, okay, I'm going to put here in the procedure a list of integers, or in the procedure, I'm often, of course, I'm going to keep giving examples, right? So for instance, I could say L, and then one uses columns to explain what L is. L is a list of integers. Okay, so that's considered a valid input. Sometimes we say L is a ordered list of integers, which means that it is being ordered in some way or another, for instance, alphabetically, if there are words, or numerically, if there are values. And we sometimes have more than just a list of, and then we have A, where A is a natural number, and it could be even more. So you can have several things that you declare, but you declare using English sentences. Okay, This is kind of a little bit cheating because it's not so easy to always implement these things in an actual language. So, for instance, sometimes we will say L is, or no, sorry, not L. Let me. We might also list it like this: A1, A2, dot dot dot, AN, and then we say AI's are integers. Where we kind of have this n, the index, the number of them is implicitly defined here. We don't mention n, the index. I'm talking about this n here, right? It is implicitly given. So that is so whatever goes into this parenthesis here is rather we allow quite a lot there. And but what we need to do is declare the input that we will have and what type of input and description of the input. Okay, so here this is a formal part, this is an informal part. Okay, there's some rules here. I said the colon is used to make the declaration of the particular type of element that you talk about. Okay, and then what is a typical command will be that you have that you declare something as a variable a is equal to, let's say, a calculation of two other variables. So you notice, okay, sorry, I was a little bit sloppy, so let me be a little bit careful here. This very typical usage of this sign here, this is the equal sign with the colon on the left, means, as I'm sure that many of you are aware of this, is a very universal usage, means that you declare A to be this guy. Okay, so this even allows us to do things like this. A is A plus 1. It's not good coding, but it allows us to do that. What it means is you take the current value of A, add 1 to it, and that becomes the new value of A. Okay, so the right-hand side is calculated using the current values, and then the left-hand side is given the calculated value. That is how this command works, but it's a very common command that one uses. For instance, we can also combine this. So these were two different things, right? So let me keep writing new things. You can sometimes have several commands. Okay, I want to be, since we are doing this. Oh, no, sorry. So A is B, and then the next command is B is C. Sorry, is this what I wanted to say? Yes. So this is one possible program, right? I'm giving a part of the program. Somewhere inside the program, or inside the pseudocode, we are writing this. One thing, we could also have written this here. B is C and A is B. You say, oh, that's the same, you just wrote in different order. But that's very crucial. We always go from top to bottom, and the order is important here. Why? Okay, so to figure this out, let's keep track of so we call these registers, right? The variables, we have the variable A, B, and C. And at each stage, they have a certain value. Suppose so this is an example, right? So I'm going to do an example. Suppose that I'm doing the same example for both of them. So we have the registers A, B, and C. And suppose that before I calculate this thing, A is 2, B is 5, and C is 3. Okay, so 2, 5, 3. So this is supposed to happen, the situation, before we get this command. Now we get to this command. What is happening? The right-hand side is evaluated, that is just 5, and A gets now the new value of 5. So the registers are 5, 5, and 3. 5 and B and C have not been changed. In the next step, B is changed. So in other words, sorry, let me keep, I'm going to do it a little bit this way. In the next command, B colon equals C. So talk about this here. The only thing that is changed is B. So let's copy A and C, and B is now declared. Oh, sorry, 5 and 3 I meant. That's 3, right? And what is B now? Well, B is to declare the current value of C, so that becomes 3. So at the end of this program, this is how the registers look like. What happens in the other program? Remember, these were two different programs, right? So there are two different programs here. Okay, so at the first stage, in the first command changes B. So let's already copy, therefore, A and C. And it changes B into C. Why keep I writing C instead of 3 here? Sorry, 3, 2 and 3. So now B is changed into C, so 3. Okay. And what is the next step? A is now recalculated. So A is recalculated in order that B and C will stay the same. And how is A recalculated? To be the value of B. Now you see that the outcomes are different. Therefore, the programs are different. Therefore, the order is important. Okay, that's one thing I wanted to point out to you. Okay, so that's the basic setup, right? Now, I said here we have seen some declaration where one variable is called another variable. We had one with expression, but sometimes we can have even things like this. Remember, if L is a list of integers, I could say that A, B, or A, it doesn't have to be A, sorry, I'll be a little bit more factual. I introduce a new variable. See, I can introduce variables at any time I want. I don't have to make a declaration. In many programs need you to do that. Here I'm saying that max be the maximum of list L. I'm cheating a little bit because maximum of list L is actually a kind of a program itself. It's a subroutine that has to calculate the maximum of the list L. But I'm either assuming that I know how to do that, or there is another subroutine that I can apply here. So we allow ourselves to put in, how to say, non-coded instructions, like we were allowed to do these non-coded instructions here. Of course, you cannot say, let max be the answer to the program, the answer to the problem. Things like that, not, right? It has to be something that but everybody can say, oh, I know that this can be programmed. Maximum of a list L, then I look into the, we'll discuss all different types of algorithms, and we will see one of the algorithms that we will discuss, one of the programs that we will discuss is to calculate the maximum of a list. So that's what I'm referring to something that is part of what we call a library of subroutines, they have different names, applets, I don't know what they are called in different programming languages, but it means something that you know how to do already. You have already figured out, or somebody else has figured it out for us. And notice therefore, so as I'm saying, this is an instruction in English. This is a new variable that I just declared out of the blue. And it gets automatically, it is what it is. Since it's the maximum of a list of integers, presumably, right? So I'm thinking myself in this situation, then this will be an integer. Okay. Right. Sometimes, okay, so now, there are the conditionals. That's a very important concept in programming, is that you need to do certain things in one way if a particular condition is held, and in another way if another condition is held. And this is the so-called if-then statements. So an if-then, and how does an if-then statement works? If, well, you're going to have a condition here. I'm going to give an example. So if n is, sorry, I have to go here. If n is 3, then let's call max, let's put max equal to 5. Okay, so this, what this will do is that if the variable n, presumably the variable n exists, like for instance, the variable n exists in this case because it was given as the length, it was basically the length of my sequence here. So if n is 3, then put maximum equal to 5. This does make no sense, I'm just giving nonsensical instruction, right? But that's something I can do. Okay, now it's not, I can even do not just one thing. I can say max is 5 and a is equal to b plus max. Okay, so I can be a list of instructions. What we also all then do is if we want to make this a little bit visually clear, so what we often will do, instead of putting the list, we put the list here, but we use indentation. So if I say if n is 3, then let's call max is put equal to 5, a is equal to put and b plus max, and then n is equal to n plus 1. Very typical is to change somehow some of these variables that you somehow are looping. So you see what I want to point out here is that there is an indentation here, right? So this we indent, and so if here now if we would put this here, a is equal to 5, what does this mean? The fact that I have stopped by indentation means that the scope of the then is finished. So the scope of the then, this is all part of then, but not the a equals 5. So in other words, if this program has to be run, if n is 3, let's see what happens then. Max will be 5, a will be b plus max, which is 5, and b we don't know what that is exactly, but that gives a, and n will be 4, right? These are the instructions that I get from here. And then in the next step, a will be put equal to 5. It's kind of a stupid program, because whatever we did here, we undo it here. But okay, I'm not trying to write a smart program. I'm just trying to say how programs work. But what if I run this program, but n is not equal to 3, then this is not carried out. If this is only carried out if n is equal to 3. And so a is put equal to 5. Okay? So, okay, let me, yeah, okay. That's, I think, hopefully more than enough. Very often, we want to do something else in case n is not 3. So what we have done here by this setup is, regardless what n is, a will be put equal to 5. This is perhaps a silly thing. So let's call this blah. Blah is equal to 5. I put blah equal to 5, that's my next step here. And instead of b here, let's make this 9 here, so that everything is concrete here, okay? So if n is 3, then this will be carried out, these steps will be carried, so max will be 5, a will be equal to 14, and n will be equal to 4, after this whole thing is carried out, and then the next step is put blah equal to 5. But I might want to do something else. What I might say, okay, if n is 3, I want to do this. If n is not 3, as it stands, the program will not do anything at this page and just will jump straight to here. But perhaps I want to do something else here, and that is the statement, so let me get rid of that, where we use else. Again, notice that the indentation has stopped, because the indentation tells me the scope of the previous command, right? So this then, how many of these things that follow are belonging to then, everything that is indented. When the indentation stops, then something new is happening, and the else, so for instance, else would now be else max max equals to 6. Okay? So let's see what happens now if this, and then I can go to the next thing, blah is equal to 5. No, I want to keep this. So in this program, as it's written now, if n is 3, then these steps are carried out. If n is anything else, 2, 0, 5, even if n is some word or something in that, this will be carried out, and so maximum will become 6. And this, there's no, okay, perhaps I should, let me show you a little bit better here, using indentation. So then max is 6, and let's say n is equal to 10. For instance, that could be, it's not, the else statement again could have a bunch of indented things, so the scope of this else is again, so this is the indented part. Whatever is indented, that's the scope of the else. And then here I would write blah is 5. Okay, so indentation tells you how far we scope. And we can nest these things. We could put an if then else inside an if then else. These examples of how complicated things can be we'll do in actual programming, but I'm just saying these are commands, and these commands can be used, or these instructions can be used inside each other. Okay, keep anything that I say can, except for procedure, of course. Procedure is kind of the initiation of the whole thing. That I cannot nest, but everything else I can start nesting things. Okay, and another is, of course, the loops. So these are the conditionals. That's basically the only conditional that we really will look at. This if then or if then else. If there is no else, we have seen that, right? Then that means there is nothing, right? So then are the loops. That's the other important concept in modern day programming. By the way, in old day programming, there was another thing. You could jumps. There were jumps where they would say, okay, jump to this and that. This is no longer considered good programming because it's very hard. It's very easy to write a code that uses jumps that is hangs. If you do jumps, you can jump. The code is it's not trustworthy, and it's very hard to debug. So jumps are no longer considered as good things. You cannot say if n is 3, then skip everything else. Skip the next 5 steps and go to this step. So that kind of conditional jumping is no longer allowed. There's one jumping that is allowed. We'll discuss this at the end. So loops. What are the loops? There are actually 2 loops. There is a for loop. So for 2, and this is where we loop. Oh no, that's not what I want to do. Sorry. This is a loop where a counter, an index, is incremented, where we start from an initial value from n3 to 7. This tells me what happens when I write this up. Whatever comes here, so for instance, I could do now a is a plus n. Now, assuming that a has already been initialized, when I write this thing, because it's on the right hand side, it means a has to be already declared somewhere before in the program. It could have been declared inside here, for instance, in this case, it could have been initiated at the beginning of the procedure, or it could have been done somewhere in the course of the program, like here, that max, or like here I have declared a. When I write this here, the only thing that needed to exist before this was carried out was max and 9. A might not have existed, and it is called into existence by this call. But of course, I have to be sure that, okay, this is conditional, so it's very dangerous to define something in a condition, right? Because then it would be undefined here. Anyways, so if A is defined, we can carry this out. Okay, and this is an example of a loop. And what is happening then? So again, let's do A, and then B is equal to the value of A, and then C is equal to the value of B, and then yeah, something like that. A couple of steps. Okay. So let's see, for instance, very quickly. Suppose here it's a little bit. Okay, tedious, but let's do it. So we have A, B, and C, and N. These are our registers, and let's see what are the values. When we start the loop, oops, I don't know what it is. When we start the loop, this tells me that N is put equal to 3. Equal to 3. Now, A, I said, already was existing, so we suppose that A was already given to be 4, say, and B and C were just 0. So assume that these values, these are just examples, this is actually declared to be here by n equals 3. Okay, n could not even exist before. This loop, it makes brings n into existence if it doesn't exist, and if it existed, it overwrites it. Okay, so perhaps, okay, let me back up a little bit to make my point more clear. So here are my registers again. So we have so the variables that we're going to have is A, B, C, and N. Suppose A had value 5, B had value 0, C was not declared yet, and N had value 8. This is before the program runs. Now, before this particular part of the program is carried out. So we start this. What does happen here? This makes N equal to 3. So whatever N was, it doesn't matter, N becomes 3. It doesn't do anything with the rest, so everything is copied. All right. So this is at the beginning of the loop. What is happening then during the loop? So remember, we have an indentation here, so all these things are carried out before anything else happens. So I do that. So A is now equal to A plus N. So we have the new A is the old A plus N. So this becomes 8 at this stage. And at this stage, nothing has happened. Nothing else is happening with the other registers. What is happening at this stage? So, sorry, this is what we're having. At this stage, B is declared to be equal to A. So B is being redefined and nothing else changes. And in this stage, C is going to be, okay, let's make C equal to B plus 1 to have something else going on. So that it would be 9 then and 3. Okay. This is the end of the indentation. That means what happens now, and this is typical for a loop, for loop, or sometimes called do loop, is that the index, the counter, so this is what we call the counter, right? This n is incremented by 1. So the next thing that happens is, so, okay, the program is carried out again, and then this is now put to 4, and everything else is just copied the same. And let's see what is the next step. Sorry, now this step carried out with these registers. Okay, the n has been incremented to 4, right? What is now happening is A is now the sum of A and 4, so this becomes 12. Okay, and nothing happens to the other ones, so they are just copied, etc., etc., etc. So this will go on all the way until the very last. If n is 7, and I'm carrying out this last step here, I don't know anymore what the values are. You can try to fill them in. It's determined, but I don't have the patience to actually really calculate it. So if this is the last thing, when n is 7, and the last command carried out is this, that means we are done with the indentation. The loop goes back. We go back to the do loop, and we get increment n again by 1. That becomes 8. So n becomes 8 now, but that is beyond the bound. That means we don't do that. I have to think a little bit. It depends a little bit on how it's defined. But so we should not count on what the value of n is. I think n gets incremented by 1, so it actually might be 8, but we don't carry out this loop anymore. We go to the next instruction that would start here, again, without indentation. Okay, that's how a for loop works. And then there's a similar thing which sometimes is easier to handle. There's a while loop. While. So for instance, here an example of a while loop. While L, oops, I keep forgetting that it's that what I have to do. While L is non-empty. Look, this is again an English sentence, right? L is non-empty. So it actually needs some programming to check that L is non-empty. And therefore, L, of course, now it only makes sense in, for instance, if L is a list, right? So I'm thinking myself now in this situation. If L is a non-empty list, then, for instance, what could we do? We could say let A be the max of L, the maximum of L. Remember, we said that we allow things, maximum of a list L, maximum of L, we know that L is a list. And then let L be L minus A. So in other words, I'm building, notice that what I'm using here is a set operation. Okay, right, in the textbook they prefer this thing, which means remove A from L. I could write it in a set notation that way, but I'm even allowed to write it this way. So, and perhaps it's better to write it this way. Remove A from L. and that's it. So the scope of this while loop, again, is this indented part. So then say, and then here say, will be something else. Let's say, for instance, b is equal to a plus 3. Stupid commands, right? I'm just doing something here. So what is happening now? How is this program interpreting this? What is happening? If we get L, a list L, and if the list is not empty, then A is going to be calculated. It's going to be the maximum of L, and then we remove A from the list L. Okay. So let's look at what happens here with the register, with the program starts. So again, I'm giving an example here. Suppose our program starts with the list 5, 3. It's a list that is at least a list always means that we enumerated things, right? I'm not saying that it's an ordered list because 5 is clearly bigger than 3, but normally when we always order from smallest to biggest. But okay, 5 and 3, sorry. L is non-empty. So when the program encounters this L, it says, okay, that's not empty, so A is the maximum. So at that point, A will be 5. Okay, that's the maximum element. And what is this statement does? It removes A from L. So the new list, L becomes 3. Okay? And that's the end of the indentation. So what happens now? Well, the while loop is going to keep checking this condition until it is no longer true. In the negation of negation means that L is empty. Well, this is still a non-empty set, so it is saying, okay, I have to still carry out this. So the next step it will do, A is the maximum of the new list, well, that is 3. And what is the new list? I remove A from it. Now I will get the empty list. Well, okay, perhaps that's not true. We have a fancy notation for that, right? The empty list. So at this stage, again, the condition is checked by the while loop. It says, oh, this is empty. I don't carry out anymore. I'm done. You can go here. And so what is B at this point? So B at this point now, at this point, B is calculated. And notice that the current value of A is 3. So B is actually 6. Okay? So that is how a while loop works. Okay? And then there is one final, and again, loops can be nested. You can put a while loop into a for loop, and you get a while loop inside a while loop. You can do a conditional inside a while loop, inside a conditional inside, and you can imagine. And this is necessary sometimes, because procedures can be very complicated sometimes. We'll see. And then there's one final command that we have to talk about. So you see the very few, right? That is return. And that is basically saying halt. And stop the calculation and return, give as answer, and then so we sometimes we don't say anything, we say just return, but sometimes we say return the value that you really asked. So for instance, in this program, I could have said return B. Okay, so if this little program that I have here was run, so let's look now at a program. I'm pasting together. So the procedure. So I'm calculating the procedure. I have to. Oh, sorry, I did forget to tell that. I'm going to normally give a procedure a name. Sorry, procedure is I have to give a name to procedure. I forgot to do that. Procedure, and sorry, here has to come as some name. My favorite program, for instance. So you give some name, which doesn't matter how many characters or how it looks like. Again, that's the flexibility of this whole thing. So return here my first proc. And my first proc has an input a list of integers. So list of integers. Sorry, I'm squeezing it in a little bit here. Okay. And this is my program. So so this is my program, right? So this is the program, and here I'm running the program. So okay, okay, I'm a little bit out of space. So allow me, okay, to just put here L, list of integers, but I need a little bit more space. So this is my program, and now I call the program. So how do you call the program? I say my first prog, and my first prog wants as an input a list L. L is a list of integers. I erased the list of integers because it didn't have space. So for instance, I can put in 5, 3 here. So the input of the program is specified in the beginning here. This is what I was talking about, right? The input could be a list, it could be several things, could be an enumerated things, it could be many, many things. Okay, so here my input is this particular list, and I call this program. So what does the program do? Let's run the program now. So if the program starts with 5, 3, so at the beginning, this is the list, right? L is declared that way because this is, L says, this L becomes the input. While N is non-empty, and then I carry out this whole thing, we have done this, we see that B is 6. And now I say return B is 6, so the program will end and will return 6. So in other words, this will say, if I run this program, so here's my prompt if you want. If you think of this as running the program, the next thing on the prompt will be 6. The answer to the program. Okay. Normally we think of this as a function that gives one value. Sometimes you need several things. So return 6, return B, as well as the list. For instance, I want to keep track of everything. So if that's the case, if I would say that, then what I would give 6, and the next thing I would give is the list, which is an empty list, so it would give me the empty list. Okay. Okay, I hope that gives you a little bit insight on how these things work. Now, sometimes we need some clarification, and there's one more notation. We use these braces here to put comments. So comment section, so we got curly braces to put a comment. So this was fun. Okay, so this is a comment. So whatever I write there is not part of the program. It's just for myself to figure out what I'm doing. Of course, real comments should be comments that explain what is going on here, what am I doing, what am I thinking of. It's not part of programming, it's just part of good programming, of being nice to the people that have to use this or debug this or gonna apply this program, that they have a little bit of more insight on what goes on. And that's it, that's pseudocode. You see, it's extremely simple, and there's really very few commands, the return, procedure, while, for, if, then, else. That's it. Okay? And we'll see, we're going to use this a lot. So I want you to, please, there's no homeworks on this, but study this, read this one more careful time in the appendix, because we're going to use this a lot, starting from next lecture.